Welcome to GCSE Maths Help. Today we're going to be looking at shape transformations exam paper questions. This video is a follow-on from my shape transformations key points video, which I will link in the bio below. If you haven't watched that video, you might find it useful before looking at exam questions. For everyone else, let's get started. So our first question says, here are 4 triangles, which 2 triangles are congruent. So in order for them to be congruent, they need to be exactly the same. So we can see that all of these triangles have got an angle that's 25 degrees, and all of them have got an angle that's 56 degrees, and they're all in the same places. So we need to work out which of the 2 triangles has the same line that's equal to 8 centimetres. So on triangle A, it's the hypotenuse. On triangle B, it's not the hypotenuse. Triangle C, it's not the hypotenuse either, but it is on triangle D. So our 2 triangles that are congruent are triangle A and triangle D. So our next question says, a cone has a horizontal base of radius 5 centimetres and height of 15 centimetres. The cone contains water to a depth of 9 centimetres. Work out the volume of the water in centimetres cubed. Give your answer in terms of pi. So in the key points video, we talked about how the top section of a cone is similar to the whole cone. They have the same proportions. So we're going to use this information to help us find the answer. So we're going to find the volume of the whole cone and then take away the volume of the top bit that's empty. So if the height of the cone is 15 centimetres and the water has risen up 9 centimetres, the height of the empty bit must be 6 centimetres. So to get from 15 centimetres to 6 centimetres, we times by 0.4. So if the cone is similar, we can do the same to the radius to find the radius of the top bit of the cone. So 15 centimetres times 0.4 is equal to 6 centimetres. We can do the same for the radius. So 5 centimetres times 0.4 is equal to 2 centimetres. So the radius at this point is going to be 2 centimetres. So now we can go about finding the volume of water. So the volume of the whole cone is going to be 1/3 times pi times 5 squared times 15, which is going to equal 125 pi. The volume of the little cone at the top, the empty bit, is going to be 1/3 times pi times 2 squared times 6, which is equal to 8 pi. So the volume of the whole cone, take away the empty bit at the top, is equal to 117 pi, so that must be the volume of water at the bottom of the cone. So looking back at the question, it says give your answer in terms of pi, so we'll leave our answer as 117 pi. It also would like the answer in centimetres cubed, so we'll put centimetres cubed at the end. So our next question says, describe fully the single transformation that maps triangle A to triangle B. So our first clue is that triangle B is a different size than triangle A, so we must be looking at an enlargement. Our other clue is that triangle B is smaller than triangle A, so we must be looking at an enlargement scale of less than 1. So if we have a look at triangle A, the base of the triangle is 6 squares long, but the base of triangle B is only 2 squares long, it's 1/3 of the size. This line here on triangle A is 3 squares long, and the same line on triangle B is only 1 square long, so that's 1/3 of its size as well. So we can conclude that the scale factor must be 1/3. So the next thing we need to do is find the centre of enlargement. If we connect up the corresponding corners of these triangles, the line should cross at a point where it's been enlarged from. So if we join up these points here and then join up these points on the other side, we can see that the lines cross at the coordinate 5, 1. So this must be the centre of enlargement. So to fully describe the transformation, we can write that it's an enlargement and the scale factor and the centre of enlargement. So this next question says, enlarge triangle ABC by scale factor -2 at centre 4, 1, which they've marked on the graph for us. So a scale factor of -2 means that we've got to double the size of this triangle, but we've also got to flip it 180 degrees. So let's start with point A. Point A is 1, 2, 3, 4 squares away from the cross. So if we flip it and we enlarge it by 2, it's going to be 8 squares away from the cross on the other side. 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be point A. So point B is 1, 2 squares across and 1, 2 squares up from the enlargement point. So we need to be 1, 2, 3, 4 and 1, 2, 3, 4 across in the opposite direction to flip the triangle over. So then lastly we're going to do point C. So that's 1, 2, 3 squares across and 1, 2 up from the enlargement point. So we need to be 1, 2, 3, 4 again, and 1, 2, 3, 4, 5, 6 away from the enlargement point. So this is going to be point C. So we can join up our points now to make the triangle, and then we've enlarged it by scale factor -2 through the centre of enlargement 4, 1. So our last question says, the diagram shows rectangles A and B. Rectangle A can be mapped to rectangle B by a single transformation. Javid says the only single transformation is a reflection in the y-axis because the rectangles are on opposite sides of the y-axis. Is he correct? Give a reason for your answer. So let's have a think how we could get from rectangle A to rectangle B. So first we could translate it by a vector 6, 0 to move it 6 places along to the right. If we mark the point in the middle of the two rectangles at the coordinate 0, 2.5, we could rotate the shape around that point 180 degrees. We could also enlarge rectangle A to rectangle B through the same point of a scale factor of -1. So we can tick no, Javed isn't correct because there's 3 other transformations that we could do to get rectangle A to rectangle B. I really hope you found this video helpful. If you would like to have a little recap on the key points on this topic, click the link in the bio below. Don't forget to subscribe to GCSE Maths Help with the subscribe button below, or you can check out my Instagram page at GCSE Maths Help for more videos and tips. Thanks for watching.